Excuse me. Hello, grade 10 students. I hope you're enjoying your weekend. As I mentioned on Thursday, this is your flip lesson assignment for the weekend. Make sure you watch this and re-watch it, and make sure you take good notes. We're starting our final topic. This is the final topic in the chemistry unit that we're completing this week. We're only going to spend a few lessons on this. It's going to be just a basic introduction to acids and bases, right? Introduction only. This will not be included on your summative assessment, but I will formatively assess you with a quiz, and you can have your notes for this quiz, and that'll occur sometime this coming week. So, what is an acid? What is a base? What do you think? What do you think an acid is? Well, would you be surprised to learn that you have many acids and bases in your home, right? On shelves, inside kitchen cabinets. These are cleaning solutions, right? They're foods. What else? They're medicines. They're beverages. There's a whole variety of common household products that fall under the category acids and bases. If you're an acid, like vinegar, or ascorbic acid, vitamin C, or oranges, or lemons, or even soft drinks, what do you taste like? Do you taste sweet? Do you taste spicy? Do you taste bitter? If you're a base, this is Drano, okay? Don't eat that. It's extremely dangerous. You use that to unclog drains. This is Windex, which is a cleaner. It's too bad we don't have just some basic soap here, because basic soap is also a base. So, what can you say about acids? What are they? What do they do? What aren't they? What don't they do? All right, what can you say about acids in your common experience with these common products? You've all experienced these products. So what can you say about acids? They're bitter. They taste bitter. They can be corrosive, right? At high enough concentrations. They can dissolve materials. They can be dangerous. We know acids can be dangerous from our work in the lab. We have to protect ourselves, especially when they're concentrated, high molar concentration. You probably don't know that they react with metals, or they can react with metals. And what acids do more than anything is they react with bases. They react with bases. What are some common acids? Well, first of all, we have to differentiate between strong and weak acids. Here are some common strong acids, also called mineral acids. You have probably heard of the first two. H2SO4 is sulfuric acid. HCl, you've worked with HCl, is hydrochloric acid. And HNO3 is nitric acid. Remember, that's the nitrate polyatomic anion. What are some common weak acids, also called organic acids? Well, C2H4O2 is acetic acid, found in vinegar. C6H8O7 is citric acid, found in lemons and oranges, citrus fruit. C6H8O6 is ascorbic acid, otherwise known as vitamin C, also found in citrus fruit. And H2CO3 is carbonic acid, which gives the bubbles to soft drinks. Okay. Here also I emphasize that acetic acid, C2H4O2, can also be written like this, because this is the same formula as that. But this emphasizes that this hydrogen bonded to one of those oxygens, that is the acidic hydrogen in acetic acid. you also see that carbonic acid is not stable. As soon as it's formed, very quickly, it loses carbon dioxide, it forms carbon dioxide, it decomposes, decomposition reaction to carbon dioxide and water, and this is what gives soft drinks. They're bubbles. What about bases? What are they? What do they do? What don't they do? Well, bases are slippery, like soap, slippery. They're also corrosive. They can also be dangerous when they're at high concentrations, and of course they react with acids. They react with acids, so bases are kind of the opposite of acids. What are some common strong bases? Also called alkali. Bases are also called alkali. Well, sodium hydroxide is a common strong base. Potassium hydroxide is also a common strong base. What are some common weak bases? Ammonium hydroxide and ammonia are some common weak bases. Now, what's the difference between a strong or a weak acid, or a strong or a weak base? What does this mean to say that you have a strong acid or a weak acid? What does that mean? Well, here's what strong acids do. Hydrochloric acid goes to H plus and Cl minus. Nitric acid goes to H plus and nitrate, NO3 minus. All right? Notice that the left-hand side is electrically neutral and the right-hand side is electrically neutral because a plus and a minus cancel each other. Now, do not think that this is ionic bonding. Just because you see a plus and a minus, you might think, oh, that's an ionic bond that bonds the hydrogen to the chlorine or the hydrogen to the nitrate. No, it is not. It's a covalent bond. It's a covalent bond. This is not ionic bonding. This is what strong bases do, and this is what weak bases do. Here's acetic acid. It also goes to H plus and C2H3O2 minus, just like HCl goes to H plus and chloride minus. What's the difference? What's the difference between this and this? Or between nitric acid and, I think that's ascorbic acid, and this? What's the difference? Okay. The difference is a strong acid has only one arrow going from the left to the right. A weak acid has two arrows, with the arrow going back to the reactant being the bigger arrow. What do you think it means? What do you think these arrow differences mean? Can you complete this sentence? Strong acids are completely what? Weak acids are only partially what? And we can say, here, I need to help you with this. When an acid fragments to give a cation and an anion, we call that dissociation. Dissociation. So, now that you know that word, can you complete this by saying strong acids are completely what? And weak acids are only partially what? Well, they're partially or completely dissociated. Strong acids are completely dissociated. Weak acids are only partially dissociated. What this means is that when you prepare a solution of hydrochloric acid, right, in water, in aqueous solution, you really have this. You don't have that, because this goes to this. This completely goes to this. It's a strong acid. But if you make a solution of, say, acetic acid, right, after some time, once this back and forth is stable, all right, and that's called an equilibrium. Once equilibrium has been achieved, and that may take some time for certain reactions, you have all three of these species, chemicals, present. Okay? In fact, you have mostly this form and very little of this form. So that's the difference. That's what this means. Okay? That's the end of this flip lesson. Please watch it twice, take good notes, and we'll pick this up in class on Monday. Thanks a lot.